Hey, here we go, section 6.3 from our trigonometry class. So we're going to be looking at the properties of trigonometric functions, and I've listed some of the key formulas that you're going to need to be aware of, and we're going to be flip-flopping back and forth between here and the unit circle when we look at some examples. Okay, so let's start with the fundamental identities. Okay, first we have cosecant is 1 over sine. And I want to explain where that identity comes from, okay? Knowing that we're talking about cosecant of theta, if we go back to our previous section, remember we said that cosecant is 1 over y, but y was sine of theta. So if we substitute for y what y is equal to, we can see that cosecant is 1 over sine. And so that's where that identity comes from. And then the next identity for cosecant, 1 over x, but x was cosine. So then we can see where the next identity comes from. Secant is 1 over cosine. Cosine is x. So secant is 1 over x, okay? And then for cotangent is 1 over tangent, meaning that cotangent is the reciprocal of tangent. Okay, so now for these two identities, you really need to know that tangent can be expressed as sine over cosine. And here's why. From our previous lesson, we know that tangent is y over x, but sine is y and cosine is x. So again, if we do substitution there, we can substitute for y and x, sine and cosine of theta. And so that's how they get this identity that tangent is sine over cosine. And then, of course, cotangent is the reciprocal of tangent. So if you take this fraction and flip it, you get your cotangent. So there's your first 5 fundamental identities that you really need to know. Next, we have 3 Pythagorean identities that you need to know. Specifically, the first one comes into play a lot. Sine squared theta plus cosine squared theta equal 1. And there's a nice little proof that shows why that is. And if you want to see the little proof that illustrates why that is, just leave me a comment in the comment section below, and I'll make a short video showing that, okay? But for this lesson, we're just going to identify that these are the Pythagorean identities, and you need to know those 3. Last, we have our even and odd properties. It turns out that if you take the sine of a negative angle, it's going to equal to sine of the positive angle, but that answer is going to be opposite, okay? So opposite of sine of the positive angle. Cosine of a negative angle turns out to be just the same as cosine of the positive angle. And tangent of a negative angle equals tangent of the positive angle, but opposite of that, okay? So these are your even odd properties. I've not listed cosecant, secant, and cotangent because they are the same as their reciprocal functions. So for example, sine is related to cosecant, so cosecant of negative theta would be negative cosecant of theta. They're going to be the same as the ones they're related to. All right, so if you have any questions so far, leave them in the comment section below or shoot me a text, and we'll keep going. Now we're going to go to the textbook, and we're going to look at examples that you're going to need to know how to do. And the first problem we're going to start with is sine of 405 degrees. And the key word here is periodic. It says use the fact that the trig functions are periodic to find the exact value of the expression. And so we're focusing on sine of 405 degrees. Now we're going to need to go to the unit circle to illustrate what they're talking about here. Okay, so here we go. Sine of 405 degrees is what we want to find. Notice that 405 degrees is not in my unit circle. So what we're going to do is we're going to spin a complete circle. That gets us to 360. And then we want to know how much past 360 is 405. And that happens to be 45 degrees more. Now, 405 stops in the same location as 45. So the sine of 405 will be equivalent to the sine of 45. These angles are not the same, but they do stop in the same spot, and therefore they will have the same trigonometric value. All right, so at this point you should know that sine in the unit circle is y, and so this answer will be square root of 2 over 2. So the sine of 405 will equal the sine of 45, and we're going to prove that using our calculator in degree mode. We're going to do sine of 405. And do you see we get the answer we got, which is equivalent to sine of 45. So the fact that it says periodic again, periodic means angles that stop in the same spot will have the same function value. All right, so let's look at another example. How about tangent of 19 pi over 6? We'll do a radian example as well, okay? So let's erase all of this. And we want to do tangent of 19 pi over 6. Now, the largest pi over 6 angle that we can get to in the unit circle is 2 pi, which is 12 pi over 6. And if you're going, how did you get that? 12 divided by 6 is 2. So I simply wrote 2 pi as an equivalent fractional expression with a denominator of 6. Okay, so do you understand a full circle is going to get me to 12 pi over 6. We need to get to 19 pi over 6. And so we're going to start at 12 and we're going to count by pi over 6 until we get to 19. So there's 12. There's another pi over 6. That's 13, 14, 15, 16, 17, 18, 19 pi over 6 is going to be equivalent to tangent of 7 pi over 6. Because if I go a full circle and then around to 7 pi over 6, that is equivalent to 19 pi over 6. Angles that stop in the same spot will have the same function value. Now you should know at this point that the easiest way to do tangent, that's the reciprocal of x times y. And so we're going to take our x coordinate and flip it over and multiply it by the y coordinate. And the 2's are going to cancel, and a negative times a negative makes a positive. 1 over square root of 3, which we would need to rationalize that. Copy and paste and then erase. Gets me square root of 3 over 3. Okay, and now we're going to prove that I didn't lie to you. We're going to go to the calculator and verify that, making sure that we're in the right mode. And we want to do tangent of 19 pi over 6. And do you see that gets the answer we just came up with? Oh, and notice my calculator gives it rationalized, which is nice. And then we're going to prove that this is equivalent, okay? So I said tangent of 19 pi over 6 should be equivalent to tangent of 7 pi over 6. Bam, same answer. So what I'm demonstrating here is how you can use the unit circle and the periodic properties of the angles to find the exact value of your trigonometric expression without using technology. This is using the unit circle. All right, so the next problem we want to look at is, let's list it right here. The next example we want to look at is, given that sine of theta is greater than 0 and cosine of theta is less than 0, they want us to find the quadrant in which theta lies. Now that means find the quadrant that this angle is in. And so I'm going to demonstrate, first of all, let me give you the shortcut. There's a little chart you can draw for sine, cosine, and tangent in every quadrant, knowing that the quadrants number 1, 2, 3, and 4. And if you remember that all students take calculus, that will tell you the trig functions that are positive in the corresponding quadrant, okay? All of the trig functions are going to be positive in the first quadrant. All students take calculus. Those are the ones that are positive. And so these other trig functions will be negative, okay? So when they say sine of theta is greater than 0, they're telling me that sine is positive. Things that are greater than 0 are positive. Cosine is less than 0, they're telling me cosine is negative. Things that are less than 0 are negative. And the only quadrant where both of these happen, where sine is positive and cosine is negative, is quadrant 2. And then you may be wondering, well, how do you know that those signs are the way they are, or what makes the signs the way they are? Well, it goes back to the unit circle. Okay, so remember that sine of theta is y, cosine of theta is x, and tangent is y over x, okay? So can you see in the first quadrant, the x coordinate is positive, the y coordinate is positive, so sine and cosine will be positive, and tangent will be a positive divided by a positive, which is also positive. So that takes care of quadrant 1, all of them positive. And then if you look in quadrant 2, you're going to notice that the y value in quadrant 2 is always positive. So sine will be positive. The x value is negative, so cosine will be negative. And if you divide y divided by x, positive divided by a negative, tangent's going to be negative. And so that's why the second quadrant is the way it is. And then the same pattern continues for the third and the fourth quadrant, okay? In the third quadrant, tangent would be positive because negative divided by a negative makes a positive. And in the fourth quadrant, notice that all of the x's are positive. Cosine is x, so cosine is positive. So that's why the chart works. You might want to know this chart for sure. Remember, I said it's easy to generate. Just remember, all students take calculus. That's a very positive statement, and you can do those types of problems. Okay? Next, let's see. I guess the next thing really we should do is go back to our notes here and look at a couple of problems that involve some of these formulas, okay? So let's, for example, let's say that you wanted to find the cosecant of 35 degrees and you want that rounded to a decimal, maybe to 2 or 3 decimal places, okay? Now, the trouble with this, with wanting this to be a decimal, is if you go to your calculator, you're going to see that you do not have a cosecant button. And so that makes knowing this formula right here handy. It says if I want to calculate cosecant of 35, really what I can do is do 1 divided by sine of 35, and then I actually have a button for that, okay? So to get that answer, that would be making sure we're in the right mode. That would be as a fraction 1 over sine 35. And there's your cosecant value, and you can round that to however many decimal places you want. Okay, so that makes knowing these identities nice, is now you have a way to calculate cosecant, secant, and cotangent if you don't have the buttons on the calculator. You can turn it into sine, cosine, and tangent. Let's see, a couple of other examples from the textbook, and then we'll call it quits for today. Sine squared 40 degrees plus cosine squared 40 degrees. And it says, use properties of the trigonometric functions to find the exact value. Do not use a calculator. Obviously, we could put this into the calculator in degree mode and have it calculate. But what we notice here is that we have sine squared theta plus cosine squared theta. Notice the thetas are the same, and that's going to be your first Pythagorean identity here. Anytime you have sine squared theta plus cosine squared theta, you know that's going to be 1. And let's pull up the calculator and prove it just this one time, okay? Angle to degrees. And this will also show you how to do a squared trig function in your calculator. You actually type it in as sine 40 squared. The squared is on the outside, but in the notes it's on the inside, and those mean the same thing. Plus cosine 40 squared. And you do need to make sure you close your parenthesis before you put the squared. And that's verified, okay? So that verifies the identity there. And one more example. Let's see. Sine of 80 degrees, cosecant of 80 degrees. Okay, and again, we're not going to use the calculator, but what we notice is that we have cosecant of 80. Knowing this identity up here, we can turn it into sine. So this is going to be the same as sine of 80 degrees times 1 over sine 80 degrees. And if you make this a fraction and multiply straight across, you can see that that's going to give us sine of 80 degrees over sine of 80 degrees. Anything over itself is 1. And so we can do that quickly knowing these identities. And that should about cover most of the important stuff in section 6.3. So if you have any questions or comments, feel free to leave those in the comment section below, or you can text me. And thanks for watching.